Now let's graph an inequality, and let's graph an inequality that's given to us in slope-intercept form again. So we'll use the inequality y is less than or equal to negative 1/3 x plus 5. We'll use exactly those same three steps that we looked at in our previous example. And so let's draw a coordinate plane. And we're using all four quadrants here. And we'll identify the x and the y axes, and then begin by plotting the y-intercept. We recognize that the y-intercept in this inequality is a positive 5. So 1, 2, 3, 4, 5. So there's our y-intercept. Next, we're going to use slope triangles to draw at least two more points using the slope negative 1/3. This time, I'm not actually going to draw the slope triangles. I just want you to know that the slope triangles are essentially the process I'm using, but I'm not writing that information on my graph. So this slope, delta y over delta x, you probably have heard other teachers use the term rise over run. Same concept. I think delta y over delta x is probably a little more sophisticated way to describe that notion of slope, so we'll use that. So delta y in this case is negative 1. Negative 1 is our vertical change, and delta x is 3. That's our horizontal change. So I'm going to start with the point of my pencil on that y-intercept that we just plotted, and I'm going to count down 1. Delta y is down 1. And then I'm going to count delta x is right 3. 1, 2, 3. And plot a point. I'm going to do that again. Start with my pencil on the previous point that I plotted. I'm going to count down 1 and right 3. 1, 2, 3. I plotted those two additional points, and then I'm going to connect those 3 points with a line. When plotting inequalities, you have to pay attention to the comparison symbol. Notice that this comparison symbol includes an equal sign. And so since it includes an equal sign, we're going to use a solid line to connect the points. If it did not include the equal sign, we would use a dashed line or dotted line to connect the points. In this case, we have an equal sign, so we'll use a solid line to connect the points. This line represents the boundary condition for this inequality. Boundary condition meaning that when we graph an inequality, we essentially divide the plane into two half planes. So we've got a region in the plane that's below this line, and we have a region in the plane that's above this line. So when we plot an inequality, we're not graphing just the line, we're identifying which half plane makes this inequality true. What I suggest we do is we use a point on one side of this line or the other to substitute into variables y and x in our original inequality and see if we get a true statement. I prefer to use the point 0, 0. So let's substitute 0 for x and 0 for y in this inequality and see if we get a true statement. So substituting 0, 0, 0 is less than or equal to negative 1/3 times 0 would be 0, and then plus 5. So is 0 less than or equal to 5? The answer is yes. So we know that 0, 0 is included in the half plane that is the solution to this inequality. I'm going to use a highlighter now and shade the half plane that is the solution to this inequality. So the half plane that is the solution includes the point 0, 0, so it's everything below the boundary condition line that we previously plotted. So our solution to this inequality is the yellow shaded region or half plane. This is the graph of the solution to the inequality y is less than or equal to negative 1/3 x plus 5.